recording this today, so, Einstein's head fell off again. I know.
She's recording.
The substitute can pause the recording at any time or rewind it in case they need a little bit more time, but does anyone want to ask a question on anything from the homework? I'm going to go over some of the problems because it reviews and leads directly into what we're going to do today. As you know, this unit, like all math units, is very sequential. We talked about rates. We made them unit rates. We set them equal to become proportions. We could solve proportions. Then we talked about finding proportionality, if it's proportional, from a graph. How do you know if something's proportional from a graph? From a graph, Mason?
If it's a straight line that goes to the origin.
He said it perfectly. If it's a straight line, that means it's constant, and it goes through the origin, then it's proportional. And we know how to set proportions up, okay? So we can do it algebraically by solving a proportion. We can look at a graph, see if it goes through the origin, and then this homework. How do we decide, looking at a table, if it was proportional? Kennedy.
So you increase by like.
She's talking about rate of change.
Yeah.
So you can do it two ways. You can say, okay, minus 250, minus 250, minus 250. 250 minus 250 is 0. 4, 3, 2, 1, 0. There's your origin. You could do it that way. Who knows another way to determine if this table is proportional? Because sometimes it doesn't go nice over here by finding the unit rate. So we always put money on top. So 250 over 1 is 250. 500 over 2 is 250. 750 over 3 is 250. And 1,000 divided by 4 is 250. So sometimes it's really nice. 4, 3, 2, 1, 0, la, la, la. Sometimes this doesn't go nicely. And so if you can't work backwards to 0 or it's getting too difficult, find your unit rates. If the unit rates are these unit rates are all the same, thank you, Natalie. If the unit rates are the same, then the relationship is there we go, okay? So that's what this was about. I wanted to spend some time talking about that to lead you into what we're going to do today. This was rate of change. When you see the word change, you have to do some subtraction. Does start with an S, okay? If sometimes you get confused and you're not sure which is the independent or dependent variable, money is always on top, which means it's what? Independent or dependent? Money depends on what you buy. So this one's easy to tell that this is Y. Sometimes it's not. Usually, top row is X, independent. Bottom row is Y, dependent, usually. So if you're totally stuck, X on top, Y on bottom. Okay? This one was really about reading and plugging it in here. And it said which represents a proportional relationship. If you have a table, how do you find if it's proportional? Raise your hand. We just talked about it. Brianne. Well, it could work backwards in the table, but this table's looking kind of confusing, right? I got two tables. What's the easiest way to determine if it's proportional? Parker, what do you think? What's the easiest way to determine if a table's proportional?
Minus 3 by 1 minus 1.
Let me see what he's talking about. Minus 3 minus 1, what are you talking about?
2 weeks minus 1 minus 2 weeks minus 1.
Oh, 3, 2, 1, 0. That's what Brianna said. You guys like that way, huh? It doesn't always work, though, so I need another way. What's my other way, Natalie? Unit rate. So what's this? 18 over 1? 18 over 1 is 18. What's this one? 36? What's 36 over 2? 18. And this was 56? What's 56 divided by 3? 1. Doesn't work, does it? So this one's not proportional because the unit rates are not always the same. You can do this one two ways. Money goes on top, divided by hours. You could get 725, and then step 2, 725 times 18. You could also set up a proportion. 108, 75 over 15 equals how much money over 18? There's two ways to do that. Okay?
Yes. Yeah, must be 6 there.
It is important that you understand something over here. This question, a lot of people have an answer with no work. And my guess is a lot of people are wrong. Here's what you need to do. You need to take each of these and turn them into a decimal. 4% as a fraction, percent means out of 100. Carson, how do you write 4/100ths as a decimal? 0.04, because 2 places make hundredths. 0.04, 4/100ths. 0.4 is already a decimal. I want to line up my decimals. A lot of kids think the shorter one has less value. Mackenzie's shorter than me. Is she less valuable as a person than I am?
Yeah.
Oh.
No, she's not. Stop that nonsense. So you can't judge a number, a decimal, based on how the length of it. Because what can I do to 0.4 to make them the same height? Length, really. Michael, add a 0. Now they're the same length. Which is less, 4/100ths or 40/100ths? Mia, I don't care. She said, I wasn't raising my hand. Yeah, nobody's paying attention. Which is less, 4/100ths or 40/100ths? Yeah, that's less. This is a really important thing for you guys to know, because those of you that have no work on your paper, I think you're missing a point. So 4/100ths is less. What's 1/4 as a decimal? Point what? 25. Now this one has a whole number, so we know that's the biggest because it has a whole number. When you write your answer, you have to write the original that's given. So that's why I like to set it up like this, because this is less, but I have to write 4%. And then 1/4. And then 0.4. You have to use these original numbers in your answer. So it's really, look how I have it set up. So I can see my original. What I turned it into is a decimal and made them all the same length. That is really important. I think you all did well on 7 and 8. I'll put the answers back up there if the sub wants to freeze this so you can check your answers. They will later today. Okay? I would like you to take out your notes. We're going to move on.
Damien called this on the subway. I'm sorry, Jamie. Somewhere.
Let's see if I can make this work. Today we're going to move one step further from rates to unit rates, setting rates equal to make them proportional, finding if things are proportional to each other. Today we're going to take it one step closer and write an equation. These are used throughout your life even if you don't see them. It's how cash registers are programmed. McDonald's, they have a picture of a French fry on the cash register and you hit French fry. And there's a formula behind that that says, how do we calculate that into the bill? Okay? So these are used in programs throughout your life that you don't even see the formula. That's why you need to come to school to learn so that maybe someday you can be a programmer. Mason.
How did you know about the thing from McDonald's?
Yeah. Did you work there? Did you break the ice cream machine?
I've never worked at McDonald's, but I know the family that developed the machine that you just hit a French fry picture and it does it. So I know they do.
What if my future job is working at Chipotle? And
That's-
what I want to do.
That's great.
Yay!
All right. So here we go. Here's a table that we saw yesterday. And yesterday we talked about number 1, if it was proportional, and number 2, if it had a constant rate of change. And yesterday we found that because we did. This was 40. This was 40. This was 40. So we found that our change in money was 40. And money goes where? You got it. Then we found our change in the cars. And we could find a unit rate from that. Gabby, what do we do to find the unit rate? Divide. What's 40 divided by 5, Damien? $8 per car. So every car that went through was $8. So if we had a cash register, we would create a formula. Remember this from earlier in the unit? And I told you, we put something in. We call that X. X is the input. Something happens in here to tell me the answer, the output. If 50 cars come through, what do I have to do to that 50 to tell me how much money I made? Cole. Yeah, multiply it times 8. So this has to be 8 times my input, 8x. Hey, y is our output. I want to know x is my input. I can put any number here, do this function, 8x, and it will tell me my output. This formula is a function, and it's what we use to put in cash registers or online when they calculate calories. You can go to Starbucks and calculate your calories, like, okay, how much is it with whipped cream? What if I take the whipped cream out? What if I put 4 pumps in? They do that. It's all based on this type of thing. This is all we're talking about today. Jackson, Cole, how to write the formula. That's it. One step further. You ready? Big question. A lot of reading here. Your mother is beginning a long road trip, and you notice that the low fuel light is on, indicating there's half a gallon left in the gas tank. This is a long sentence. What's the only thing I need out of this sentence? Jack Clark, what's the only thing I need to know out of that first sentence? I don't need to know it's my mother. Yeah. All of this stuff is sort of setting up the scene. We know we're driving. We know we have gas. What I really need to know is that there's a half gallon. I don't care if it's your mother, your brother, you. I don't care. The nearest gas station is 26 miles away. Your mother keeps a log where she records the mileage and the number of gallons purchased each time she fills up. So here's the record. Oops, I didn't mean to do that. Here's the record your mother keeps. Now, my car's programmed to tell me this. Yours probably is too. Maybe someday you're going to grow up and be an automotive programmer. You know, you take your car in, something's wrong with it, they just plug it in and a computer tells you what's wrong with it. Maybe you're going to be that. We don't know. My car tells me this. We're going to figure out what this car's program would be. First, I want to know, is this a proportional relationship? How would I find that out? How do I know from a table if it's proportional? We've talked about this today. How would we know? Dylan? Yeah. Usually, if we're not sure which is the independent or dependent, we go with this is X, this is Y. Dylan said 112 divided by 4. Do it. What's 112 divided by 4?
It's something.
28.
Who said it? 28. Okay. Now what? Now what, Cole?
Something.
We're going to do this one. Y goes on top. 168 divided by 6. What is it?
28.
Kennedy, what now?
224 over 8.
It's 28.
Since they all have the same unit rate, they are proportional. Yes. They each have a unit rate of 28. Rhymes. Unit rate of 28. Mason, Carson, I was worried about that seating arrangement. A. Find the constant rate of change. When you see the word change, it indicates you're going to have to do what? Subtract. So let's subtract these. What's 224 minus 168? I wondered why you were just staring at your calculator and not using it.
Oh, we're supposed to be doing that.
56. What's 168 minus 112? Don't guess. Type it in.
56.
Oh, I got it. Oh, I got it.
168 minus 112. Do it. Jackson. 56. So my change in miles is 56. We're going to put that over change in gallons. What's the change in gallons? Cole? 2. What do I do with that ratio? Divide it. What do I got? 28 miles per gallon. In this case, my unit rates were the same as my rate of change. It's not always that way. Hey, guess what? We're going to write an equation. It's always in this form. Y equals unit rate times X. What goes in that box? McHenry, what goes in that box? What goes in this box? What's my unit rate? Well, we've found it twice in 2 different ways. Come on. Yeah! So So in that box, I'm going to put 28. Y equals 28x. This is the formula that goes in my function machine. So I know, my car knows if I type in how many gallons of gas I have, how far I can go. It knows what's left. All right, remember, Mom only has a half a gallon left, and the gas station's 26 miles away. So we're going to use this formula. What's my gallons that I'm going to plug in here, Mia? How much does Mom have? How many gallons does Mom have in her tank? Half. So we're going to do, we want to know how far she can go on a half a tank of gas. What's half of 28? Michael Toulson. She can go 14 miles.
That's not right.
Oh my gosh.
Oh.
Will she make it to the gas station? Mason says a half a gallon will only go 14 miles. Mom won't make it. You don't have to have the exact word. Throw it neutral. Everybody lean forward. I don't know. You don't have to have my exact words, but you can't just write, she won't make it. You have to explain it, so you need a sentence. Next question. Allie, ready? Using the equation found in part B, y equals 28x. Determine how far your mother can go with 18 gallons of gas. Where does the 18 go? In place of x. Y equals 28, parentheses, 18. How far can she go? Mackenzie.
That wasn't you.
You've got a calculator in front of you. $504 miles. Kind of cool how it's all related, huh? Input-output machine. Now we have an input-output formula. I love this. We're going to skip example 2 and do this one here. No table or graph, just words. There are 3 cans that store 9 badminton birdies. I left out a word. Consider the number of birdies per can. Money's not involved in this. I don't know which is my independent and dependent variable. Any thoughts on how I decide what goes on top? Jack, do you have a thought? How do I decide what goes on top? Michael? Any thoughts?
I think that's this and this and then.
This and this. Read the words. What does it say? What and what? You're right. What does it say, Natalie? Birdies per can. The question tells you what is the independent and the dependent. A, find the constant rate of change. How many birdies in the can, Jaden? How many birdies? 9. How many cans, Damien? 3. What do I do with those 2 numbers, Carson? Divide them. What do I get, Kennedy? 3 birdies per can. Question says, write an equation. This is part A, part B. What's my equation? Parker, what do you think? You got it, man. Y equals 3x. That means 3 times however many cans there are. Great. In 25 minutes, Lee can run 10 laps around the track. Consider the number of laps she can run per minute. There's no money here. I don't know which is the independent and dependent variable. How am I going to decide what goes on top, Gabby? The words, you got it. Laps per minute. Laps is dependent on minutes. What numbers am I going to fill in, Mason?
25.
What goes in the numerator?
10.
10 laps. 10 goes in the numerator.
5.
Over 25. What am I going to do with those two numbers, Toulson? What? Divide them. 0.4. 0.4 laps per minute. She doesn't even run a half a lap in a minute. Less than half a lap. That's A. B. Who wants the equation? Kennedy. You got it. So we're taking everything you knew about finding unit rate and constant rate of change and just today throwing it into an equation. That's it. All right? I'm going to hand out your homework. It is due tomorrow. You have... Huh?
Wait, this all baby watches